Thank you, Xizini, for great introduction. And hello everyone, I'm Zhengchen, a product manager from Alibaba Cloud, and I'm very honored to introduce our newly released database product, Tair Serverless KV. And in today's presentation, as you can see on the slides, I will be covering three main parts. The first one is we will walk through the evaluation of the product Tair, and then I will explain the key feature of the Tair Serverless KV, and you will know what it is and why you need it. And finally, we will go over some real-world use case, and let's get started. Now, let's start with the evaluation of Tair product. 16 years ago, back to 2009, we launched the Tair MDB, our first high-performance in-memory cache. This was where it all began. And in 2011, we took our first step toward persistence with Tair LDB. And then in 2022, we introduced the Tair Cache, a cloud-native, memory-optimized version of the Tair designed for ultra-low latency, delivering sub-millisecond response times. And this was the natural evaluation of Tair MDB built for the modern cloud environments. And with the rise of the AI, we've also expanded the Tair product line. Last year, we launched the Tair KV cache to meet the caching need of the AI area. And this year, we are pleased to share with you the launch of our new product, Tair Serverless KV. After Tair MDB evolved into Tair Cache, we've also made comprehensive upgrades along the persistent storage path. Evolved from Tair LDB, Tair Serverless KV is a high-performance foundational KV database. It currently supports Redis and plans to support DynamoDB in the future. Then let me walk you through the product features of the Serverless KV and explain why you need this product. As we know, today customers face many challenges with traditional KV database. For example, sudden traffic spikes can crash a system immediately. And at the same time, users are less and less tolerant of the slow response times. And the fixed resource cost of traditional database are becoming harder to build. And these issues bring really performance concerns to users. Meanwhile, for the company, they also face the headache in the capacity planning. It's difficult to predict the demand, and the resources are hard to estimate. During operations, limited elasticity in traditional database products lead to a series of the operational problems, and that's why we built the Tair Serverless KV, which can solve these problems. It delivers the seamless elasticity. It can automatically adapt to workload changes with no manual intervention needed. And it's also as pay-per-use. It maximizes resource utilization and keep costs under control. And also the extreme stability ensured through the multi-layers architecture that guarantees low latency and high availabilities. And most importantly, it is persistent and reliable storage. So unlike traditional database like Redis, which is designed mainly as a cache, the Tair Serverless KV is a foundational KV database that is fully persistent and automatically scale with your workload. Plus, we maintain full compatibility with the Redis API. This means broader use case and a much lower learning curve for you. Among all features of Tair Serverless KV, one that deserves special emphasis is its elasticity capability, which include both vertical scaling and horizontal scaling. In short, vertical scaling means when a shard computing capacity is no longer enough, the system automatically increases CPU and memory to boost performance. And this is especially effective for the handling hot-key issues. And on another hand, a horizontal scaling means when the number of shards is insufficient, the system automatically adds more shards to improve overall cluster performance. This works best when there is no single hotspot, but the cluster's total load is steadily growing. And here's the key. As number of the shard change, the data is automatically rebalanced in the background with zero impact on the user. So you do not need to worry about it at all. And you can see the diagram on the right to help you understand real elasticity and the responsiveness of the serverless KV. Firstly, the elasticity threshold is set at half of the current load limit. Once usage exceeds 50%, scaling up is automatically triggered. And secondly, each scale up double the overall performance. And thirdly, the first scale up completes with seconds. And for consecutive scale ups, each takes about 30 minutes. This means if it's been more than 30 minutes since the last scale up, the next one can happen immediately. However, if less than 30 minutes has passed since the last scale up, the traffic continues to rise beyond the current capacity, and rate limiting will be applied temporarily. But once the scale up finishes, the rate limiting is lifted immediately. Finally, when rate limiting happens, some client requests may experience higher latency because those requests are queued. But to give you control, we also provide configurable rate limiting mode. You can choose to adjust so that the requests are subjected to rate limiting will directly return the error instead of being queued. So this can help prevent client connection explosion in extreme scenarios. With these capabilities, serverless KV can automatically adapt to your application workload seamlessly and in real time. And as we know, latency control is at the heart of database performance. Traditional KV databases often struggle with unstable latency because they face several key challenges. Firstly, high concurrency workloads. When Tair handles massive concurrent requests, like in an e-commerce flash sales, traffic can reach millions of requests per second. Under such pressure, increased resource contention can cause requests to queue up, leading to latency spike and fluctuation. And secondly, performance bottleneck or blocking caused by slow queries. Because we are Redis compatible, we support hundreds of commands. Some compute-heavy commands like sort can consume significant CPU. Meanwhile, high I/O commands such as fetching a large key with get can block other requests, increasing tail latency. Thirdly, misuse or interference from administrative commands. In certain scenarios like configuration changes or cluster metadata updates, control commands must be proceed reliably. But if these are mixed with regular user requests, they may compete for resource. This can delay critical operations and even lead to the cluster state anomalies. And finally, background tasks inside the database, such as persistent compactions. If these internal processes share resource with user-facing requests, they can introduce performance jitter, causing unpredictable delays. And these are common pain points in traditional systems. They directly impact your application's responsiveness. As we can see in the lower left image, traditional KV databases often suffer from latency spikes. The response times are highly unstable. To address this challenge, Tair Serverless KV has made a series of key improvements. We call this solution real-time priority scheduling. By classifying request type, separating control flows, and running background tasks asynchronously, we ensure that critical business requests always get low latency response. And how does it actually work? Firstly, Tair Serverless KV use multiple threads architecture, and the number of threads automatically adjusted based on the workload, ensuring optimal resource usage at all times. And secondly, we've introduced this dynamic thread scheduling. Each request is analyzed in real time based on its time complexity and expected execution duration. Then we classify the request into the fast and slow categories. Use the priority queue. The fast and slow requests are separated, and the running requests are moved to the slow path. So a single slow operation will not block the entire instance. To prevent control command misuse from causing issues, all administrative commands like config changes or metadata updates are handled through the dedicated threads and separate ports. This completely isolates them from the regular user request processing, so control operations remain stable even under heavy traffic. At the same time, common background tasks such as TTL expiration, compaction, and garbage collection are offloaded to the dedicated helper threads. They run in the background without interfering with the foreground user request. As a result, we achieve the stable latency even under complex high concurrency workload. And this improvement is clear shown in the image at the lower right, where you can see much smoother, consistent response times. After achieving low latency request processing through our real-time priority scheduling, the next critical part we need to adjust is latency control in the storage engine, because Tair Serverless KV is a persistent KV database, and the data is automatically stored across multiple layers. Memory cache accelerates access to the hot data, while the storage layer handles real-time persistence of the old data. The storage engine of the serverless KV is built on log structure merge tree. We can call it LSM tree, a model known for excellent performance in write-heavy scenarios. However, LSM tree has a well-known weakness, write blocking. Under high write pressure, the background operation like compaction and flashing can consume heavy resource, causing incoming write requests to be blocked. Once write blocking happens, client request latency spike dramatically. In worst case, the system might even stop accepting write completely, leading to service outage. The reason of LSM tree write blocking is closely related to its flashing mechanism, compaction mechanism, and the I/O performance of underlying storage hardware. As shown in the lower left diagram, under continuous high write load, the RuxDB write performance drops quickly and fall close to zero. To solve this problem, we've made a significant improvement. We dynamically analyze the available storage I/O capacities in real time and calculate how much write load the storage engine's background operation can handle. And we then introduce a traffic token mechanism. Based on the instance historical write pattern, we build a dynamic and intelligent token bucket. Every write request must acquire a write token before proceeding. If the incoming load exceeds the model capacity, the new requests are rate limited to prevent system overload. This is our traffic controller. It dynamically balances the foreground and background write I/O according to actual workload and automatically adjust based on business needs, avoiding I/O exhaustion and potential cascading failures. Finally, as shown in the image on the right of this slide, under the same high write pressure scenario, write performance does drop, but it stabilizes and never falls to zero. And once the instance scales up, the performance issue will fully resolved. And in distributed KV systems, hotkeys are also a key factors that affect low latency performance. When access to specific key suddenly spikes, it can overload local resource causing latency to surge or even lead to service collapse. To solve this, Tair Serverless KV uses the three-layer mechanism: the detection, caching, and control. To identify and manage hotkey traffic, we use a sliding time window to monitor the QPS of each key in real time. The system will count the keys with a sudden QPS surge in the past 1 second and automatically identify the top 50 hotkeys, and the process has almost no impact on the performance. And for example, if the key QPS rise from 2300 at 2.7 seconds to 7200 at 2.9 seconds, the system marks it as a hotkey and triggers follow-up actions. And the system also allows you to set the QPS threads freely between 100 and 100,000, so it can adopt different business scenarios. Once the hotkey is detected at the DB node, the system pushes the result of that key into the drum cache on the proxy node. When the client requests this key again, the proxy directly returns the cache result without forwarding it to the backend DB, significantly reduce the query latency. At the same time, to prevent malicious traffic or some specific sudden traffic, our system also supports controlling the traffic of the hotkeys by setting custom rules. For example, we can use the command shown on the slide. You can limit QPS any key starting with the A to 0, or using the tracing log at the rule plus L push to capture the traffic logs for specific commands. Once the rate limiting threshold is triggered, the system immediately blocks the abnormal request. In addition to elasticity and stable low latency, the serverless KV also offers high availabilities and full data persistence. For high availabilities, it uses dual AZ and dual replica development. This means every piece of data is stored in two separate availability zones. If one zone fails, the system automatically switch to the replica in the another zones, ensuring continuous service availability. On top of this, we also support the development of 3 availability zones to address the scenario with higher disaster recovery requirements. For data synchronization, we offer 3 flexible modes to meet different business needs. For sync, semi-sync, and synchronous, users can freely choose the mode that best fit their needs. And for persistence, we provide both full backup and incremental backup. Full backup supports automatic scheduled backups as well as manual on-demand triggers, more flexible options to adopt different scenarios. And the incremental backup is log-based and fine-grained, allowing fast rollback to any point in time. For example, if the data is accidentally deleted, you can quickly restore the instance to its state before the incident. With these capabilities, the Tair Serverless KV delivers extreme reliability for your business. And so far, we have understood that Tair Serverless KV is very powerful and a fully persistent database service with many advantages. For example, we support Redis and plan to support DynamoDB, and the learning curve is low. At the same time, we offer reliable persistence and fully recovery capabilities while maintaining low latency. And moreover, our deployment is very simple because the programming interface of our cache layer and the persistence layer are same, and the code complexity has decreased significantly. And finally, our single instance can support millions of access and achieve second layer elastic scaling, help business smoothly cope with the traffic fluctuation. And next, let me show some use case of the Serverless KV to help you better understand its value. Firstly, search advertising and recommendation as the core service in internet industry has several key features like the sudden traffic spikes and the strict low latency requirement and the stronger cost sensitivity. For example, during e-commerce shopping festival, traffic surged dramatically and the user demand faster response, and companies face the pressure to control costs. With self-built clusters, you must provision resource for peak loads, which lead to waste capacity during off-peak period. These are exactly the challenge that the Tair Serverless KV can solve. And because the serverless KV is Redis compatible, so in the sub-millisecond latency scenario, you can use Redis as the cache and use the serverless KV as the persistent KV database and managed with the single code base. It's greatly reduce the development and operational cost. And for the latency sensitive online application like transaction systems, the data can be read and write in real time from the Redis cache. And for the analytics workload, data can be write to the cache for immediate access, while also being batch written to the serverless KV for the durable storage. And also for the AI scenarios, the massive amount of data generated is almost the unstructured KV data. So at the same time, AI workloads has more diverse storage requirements. They need low latency session storage, long-term memory, code-based indexing, and inference scheduling, and KV cache to support inferencing performance. And in this case, Tair Serverless KV provides a unified KV layer handling the demands of the online application for high concurrency, low latency, and automatically elasticities. It enables efficient collaboration across intelligent cockpit systems, AI-powered coding tools, conversational AI search, and inference infrastructures. And in gaming scenario, global state include shared game data such as the leaderboard, system announcements, and chat room, and so on. So this data requires fast read and write access must be available to all players in real time. Therefore, the high concurrency and low latency features of the serverless KV can well meet these requirements. And the data that need to be stored in the player equipment, such as the personal items and the task progress, are usually also stored in the form of KV. So the serverless KV is naturally suited for the gaming use case, and with the auto-scaling capabilities, it can easily handle this fluctuation in the traffic and scaling up during the peak hours and down during the quiet periods without any manual intervention. And other applications in the internet field cover multiple areas such as e-commerce and local life and air travel. The serverless KV play a key roles in these scenarios. With its millisecond level access speed, it enables real-time experience such as instantly display the product information on e-commerce site or allowing user to see up to the minutes price change in the travel apps. And in summary, serverless KV with its strengths in persistence, high elasticity, high performance, and pay-per-use pricing perfectly meets the demanding data storage requirement of AI, gaming, and other internet application. Finally, thank you very much for watching up to this point. I hope above introduction can better help you understand Tair Serverless KV, and also hope that the Tair Serverless KV can truly help you better solve the problem you encounter in your business. That's all. Thank you.